Welcome back. Today we are going through lesson 3.1, which is all about function basics. So this unit's going to be about functions and graphs. So we're going to start off with the basics today. The first thing is what is called a relation. So a relation is a set of ordered pairs, so x's and y's, and there's 4 different ways that we are going to display those relations. So the first one you can see here is what we call a mapping diagram. It is showing what x value goes with each y value. So we can see that these arrows are indicating that -2, 2 is a point, or for example, this one, 4, 0 is an ordered pair. The second one is an xy table. Same thing, we can see which x values are matched up with which y values. Then we have a graph. So we can see those coordinates on the graph. And then the last one we have is an equation. So those are the 4 ways we can display a relation. Some key points about those. So the first thing is the domain. Domain is all the x values or input values in a relation. And those are our independent variables. The range is the opposite of that. That's all our y values. Those are all your output values. And they are the dependent variables. So you've got your domain and range. And then we also have discrete and continuous. So a discrete relation is one with distinct points. So they're not connected, they're just individual points on a graph. Continuous is where they are connected lines or curves. So that's where it's an actual line. All right, so once we have a relation, we can also sometimes have a function with that. So a function is a relation where each member of the domain is assigned to exactly one member of the range. So each x has one and only one y. That means that x values cannot repeat. So the way we test for that is something called a vertical line test. So this is where we draw a vertical line on our graph. And if we can draw a vertical line somewhere where it touches more than one point, then it's not a function. If we can draw a vertical line and it only touches one point, that means it is a function. So let's look at some examples here of some ordered pairs. So looking at our graphs above, if we look at the mapping diagram up above, we can see those x's and those y's. So our domain would be that left circle, which is -2, 0, 1, and 4. And then the range, the y's, we want to write in order from smallest to biggest. So your order matters here. So if I look at that y circle, I've got -4, -1, 0, and 2. And so I'm going to put them in order. So if I look at this, I can see that if we look at the picture, it's kind of easy to see that this x value goes to 2 different y values. That's a problem. That's not allowed. So it is not a function. And then discrete or continuous, this is just a bunch of points, so it's discrete. There's no connection between them. All right, now looking at the table. So if I look at the table there, I see that it has a -7, a -1, and a 4. We don't write down any repeats. In the range, looking in that right-hand column, I see a 0. Oh, let's write them in order. The order matters there. So let's go -5, -3, 0, 1. And again, that x value of 4 repeated, so that is not a function. And again, it's just individual points, so it is discrete. We don't see like decimals, or there's just not all the points are possible. All right, the graph on number 3. So this one gets a little interesting. Since it's not individual points, we can see that it's that U shape going out forever. So the domain on this one is actually -∞ to +∞. because it goes on forever. Almost the same thing in the range. But in the range, the y values, the lowest y value it gets down to is 0, and then it goes up to infinity. So that is a function. It passes the vertical line test. And since it has a curve on there, that is continuous. All right, then we have our equation, negative 2x plus 4. So that's a linear function, which means I can plug in any x value I want, negative infinity to positive infinity, and it'll give me all the outputs, so negative infinity to positive infinity there also. That is a function, it's a line, and it is continuous. So those are some function basics. Let's talk about some function notation now. So in function notation, we use f of x, is how we say it, f parentheses x, instead of y. So it's just a different way of writing it, but it represents the same thing. So in an equation, we have y equals 3x plus 8. To write that as a function notation, we write it as f of x equals 3x plus 8. So again, just a new notation, doesn't change the value or anything. So when we plug in x equals -1 to the equation, it would look like 3 times -1 plus 8. And we would simplify that to 5. Same thing in the function notation. Notice that we put the -1 in here for x, but notice it doesn't change the value. You don't have to like solve for f or anything like that. It's just a notation way of saying it. So we're going to look at some functions and we're going to evaluate them for each given value. So we're going to fill in this table down here. So for each function, we're going to plug in -3 to start with. So in this equation here, I'm going to plug in -3 for x. When I do that, I get -3 squared plus 4 times -3 and minus 5. When I simplify that, I get... So when I plugged in -3, I got out 8. Oh, that should be a -8. Sorry, -8. It's -3 minus 5. All right, in B, if I go to -3 on that graph and I follow it up, I can see I would have an output of 5. And then in function C here, I can see that when the input's -3, output is -8. All right, let's do f of 0 now. So looking at 0 for each one, plugging it in to A, I get 0 squared plus 4 times 0 minus 5, and that is -5 when I simplify. So I'd have -5 for that one. When I plug in 0 on the graph, I follow it up and I can see that it's at 2. And in C, that is at 0. Lastly, we have 1. So we're going to plug in 1 here. We get 1 squared plus 4 times 1, that would be 5, minus 5 is 0. So when I plug it into the function, I get 0. On the graph, when I go to 1, I follow it up and it's at +1. So 1, 1 is that point. And on the table, I have 1, -5. And that is my output. So those are some function basics and function notation. We'll see you next time.